NEET previous year questions, very important questions. Listen very properly. Yeah, first one, the most stable carbocation among the following. Hmm. So everybody knows most stable carbocation means tertiary greater than, secondary greater than, primary greater than methyl carbocation. Clear? First you just identify. First one is primary carbocation. Second one is 3 degree. This is 2 degree. This is also 2 degree. Very simple question, direct question. Second one is the more stable. Next question. A compound with a molecular formula of C6H14 has two tertiary carbons. Yeah. C6H14 should be molecular formula and it has two tertiary carbons. Just look at option B. This is the structure. CH3, CH, CH3, CH, CH3, CH3. Yeah. So this is 1, this is 2, this is 3, this is 4. 2, 3 dimethyl butane and molecular formula C6H14. Clear? Yeah. And this carbon is 3 degree carbon, this carbon is 3 degree carbon. It has two tertiary carbons. Clear? Yeah. Next question. Which among the following compound will show geometric isomerism? Yeah. So in simple point, terminal alkenes do not show geometric isomerism. Terminal alkenes. But what was the condition? Each double bond carbon should have different attachment. In alkene, each double bond carbon should have different attachment. Then only geometric isomerism possible. Yeah. So first, what was option A? Pent 1ene. CH3, CH2, CH2, CH double bond CH2. This is pentane, one pentane. Is it terminal alkene or not? Yes, terminal alkene. Terminal alkene means it not shows geometric isomerism. Next, 2, 3 dimethyl but2ene. 2, 3 dimethyl. Yeah, this is a 2, 3 dimethyl butadiene. This is not terminal, but here one problem is there. So attachment, this carbon, have a look. So this is a double bond carbon and this is a double bond carbon. So double bond carbon having similar attachment, methylo. Here also methylo. But what was the condition? Different attachment, then geometric isomerism possible. So technically this one also not possible. Next, 2-methoxypropene, 1ene. 1ene means that is a terminal. Clear na? Yeah. This is 1. This is 2. This is 3. Yeah, this is 2-methoxypropene. 1ene is nothing but terminal. This one also not shows. So what is the right answer? Yeah, D is the right answer. 3, 4 dimethyl hexythreene. CH3, CH2, CH3 double bond CH3, CH2, CH3. 1, 2, 3, 4, 5, 6. 3, 4 dimethyl. Clear? And one more important point, this is a double bond carbon, this is a double bond carbon. So this carbon, methyl group is there and ethyl group is there. Same logic. This carbon, methyl is there, ethyl is there. So each double bond carbon should have different attachment. That's the reason this one shows geometric isomerism. Clear? Yeah. Next, the number of sigma bonds and pi bonds and lone pairs of electrons in pyridine. Yeah. So pyridine or pyridine both are same, no problem. Pronunciation is not at all matter. Structure is important. Yeah, this is pyridine. This is the structure. Clear na? Yeah. There are 3 double bonds. So 3 double bonds means 3 pi bonds and 1 lone pair. Next, molecular formula. C 1, 2, 3, 4, 5. Yeah, C5 H5 N 11. Total number of atoms 11. And this is monocyclic ring. So now, when it comes to monocyclic ring, one formula is there. Sigma equal to total number of atoms, which means 11 sigma. Clear na? So 11 sigma, 3 pi, 1 lone pair. Yeah. B is the right answer. Next one. Consider the following compound species. There are 7 compounds. The number of compounds species which obey Haeckel's rule. Yeah. So what is the aromaticity Haeckel's rule? 4n plus 2 into pi electrons. So here n is nothing but integer. N equal to 0, 1, 2, 3, 4, like that. Yeah. If you substitute n equal to 0, then it becomes like this 2 pi. If you substitute 1, it becomes like this 6 pi, 10 pi, 14 pi, 18 pi. Clear na? Yeah. First one is naphthalene. Naphthalene కంటేను 5 double bonds. First, actually aromaticity 3 conditions are there. First condition, compound should be cyclic. Second condition, fully resonance. Third condition, it satisfy Haeckel rule. Clear na? So 10 pi electrons are there. If you look at second one, 6 pi electrons are there. But you will get one doubt, sir. Only 2 double bonds are there, na sir. But negative charge is there, na. Negative means lone pair. Here lone pair involved in resonance. Because of that reason, you have to take like this total 6 pi electrons. Next, this is 1 comma 2. No. 1 comma 3 butadiene. Only 2 double bonds, so which means 4 pi electrons. So this is a double bond and lone pair also we have to consider. Total 4 pi electrons, total 2 pi electrons, and total 8 pi electrons, and total 14 pi electrons. Yeah. You just look at these pi electrons, you can understand. First one contain 10 pi electrons. Yeah, first one is aromatic. So first one is aromatic. Next, second one 6 pi. So that is also aromatic, 6 pi. Next, third one 4 pi, not aromatic. Fourth one not aromatic. Fifth one aromatic, 2 pi electrons. Fifth one aromatic. Next, fourth one only 4 pi electrons, not aromatic. Okay, sixth one 8 pi, not aromatic. Next, seventh one 14 pi electrons, that is also aromatic. Clear na? Right. Clear? So here this is not aromatic, this is not aromatic, this is not aromatic, whereas remaining aromatic. So total how many? 4. 1, 2, 3, 4. So D is the right answer. Clear na? Yeah. Next one, what is the hybridization shown by C1 and C2 carbons respectively in the given compound? Yeah. So this is the given compound. CH double bond CH, CH2, C double bond O, CH3. Technical problem is there, 2 is there. Yeah. So this is 1, this is 2. So carbon single bond is there, sp3. Here carbon double bond is there, sp2. So anyhow, C1 sp3, C2 sp2. So D is the right answer. So what is the right answer here? D. Next one, which of the following is most stable carbocation? As usual, this is a tertiary carbocation, this is secondary carbocation, this is a primary carbocation, this is a secondary carbocation. And one more important term, this is not only tertiary, here resonance also possible. Clear na? Double, single, positive is there. Resonance possible. Resonance possible. Next, actually hyperconjugation also possible. Hyperconjugation also type of resonance. Actually this is 2 degree allyl, which means resonance also possible. Yeah, generally 3 degree is more stable, but here hyperconjugation resonance also possible. Undoubtedly first one is the right answer. Next, which compound among the following is not an aromatic compound? So here 6 pi electrons are there. This is a tropylium ion. Here also 6 pi electrons are there. This is cyclopropyl cation. Here 2 pi electrons are there. Yeah, this is not cyclic planar. Why? Because this carbon is sp3. Okay, now this is non-aromatic. So anyhow, among the following is not aromatic compound. Fourth one. Next, the correct IUPAC name of the following compound. First take numbering. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Yeah. So alphabetical order: 1 bromo, 5 chloro, 1 bromo, 5 chloro, 4 methyl hexane, 3 all. First option correct answer. Next, the compound which shows metamerism. Generally, ether shows metamerism, but which type of ether shows metamerism? That is important. Minimum 4 carbons required to show metamerism. Direct. Chennai is the correct answer. CH3, CH2, O, CH2, CH3. Yeah, there are 4 carbon and 10 hydrogen. Actually, this is a symmetrical representation. You should convert into unsymmetrical like this. CH3, CH2, CH2, O, CH3. So what is the relation between these two? Metamers. Clear? Yeah. Next, the correct structure of 2, 6 dimethyl hex 2, 6 dimethyl decphorine. Yeah. Look at which one suitable. 2, 6, 1, 2, 3, 4, 5, 6. Yeah. Look at C, option C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. 2, 6 dimethyl decphorine. Yeah, no. This is not. This is 5A. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 6 dimethyl. Yeah, this is the right answer. So last one, D is the right answer. Next, a tertiary butyl carbocation is more stable than a secondary butyl carbocation. What is the reason? Plus I or effect of CH3. This is also one of the reason. Minus or no. All alkyl groups comes under plus R only. Next to actually plus R. Sorry. Plus R means resonance effect. No. Don't take option A. Don't take option A. Option B. Option C, hyperconjugation. Yeah, tertiary butyl carbocation hyperconjugation possible na? Yeah, possible. There are 9 alpha hydrogens. Increase the alpha hydrogens, increase the stability. Very simple question. Yeah. Next, 13. The number of sigma and pi bonds present in pentatoene 4ine. First to take structure. CH3, CH double bond, CH, C triple bond, CH. Yeah, this is 1, this is 2, this is 3, this is 4, this is 5. Yeah, this is a pent. No. Don't give numbering like this. You should give numbering like this. 1, 2, 3, 4, 5. Yeah. बट एक्चुअली दिस इज द एग्जैक्ट नंबरिंग बट क्वेश्चन में ऐसा दिया ना हम क्या करते हैं क्वेश्चन फॉलो करना पड़ेगा इसलिए ऐसा ले लो ठीक है ओके 22 या ओके how many pi bonds triple bond is there triple bond means 2 pi bond double bond is there 1 pi bond there are 3 pi bonds that's it 3 pi bonds only one structure na to find sigma bonds one formula is there this is open chain compound when it comes to open chain this is the formula sigma equal to total number of atoms minus 1 how many carbons are there 5 carbons how many hydrogens are there 3 plus 1 4 5 6 total 11 so 11 minus 1 means 10 so 10 sigma yeah first option right answer next which of the following molecule represents the order of hybridization sp2 sp2 sp sp from left to right left to right left to right means like this look at first one sp all or sp no look at second one yeah second one is the right answer ch2 double bond means sp2 c double bond means sp2 c triple bond means sp c triple bond means sp right next one which of the following carbocation is expected to be more stable yeah NO2 is there, carbocation is there, NO2 is there, carbocation is there, NO2 carbocation, NO2 carbocation. Yeah. So NO2 is nothing but electron withdrawing group. Electron withdrawing group inversely proportional to stability of carbocation. Clear? Na? Here distance is very, very important. Clear? More distance means less minus I effect. Less minus I effect means somewhat better. Clear na? If you look at second one and fourth one, carbocation directly attached to NO2. So here NO2 destabilize the stability of carbocation. So second one or fourth one least stable. Here distance is there. That's the reason this is more stable. Yeah. Next, the IUPAC name of the compound. So among all aldehyde is major. That's the reason this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Yeah. Tell me answer. 2, 2 methyl. 1, 2, yeah, 2 methyl. 3 keto, yeah, 3 keto, 2 methyl hex 5 no, not 5, 4, 3 keto, 3 2 methyl hex 4 yeah, this is the right answer. Have a look, you can understand. Next, which of the following statement is not correct for a nucleophile? Yeah, so nucleophile means more electron density. Nucleophile means stable. Nucleophile means Lewis base. Nucleophile definition, nucleophile, nucleus loving species. Nucleus loving species. Clear? Yeah. So what was the question? Which of the following statement is not correct? Nucleophiles are not electron seeking. Yes, correct. Nucleophile not electron seeking. Electrophile or electron seeking. Yeah. Nucleophile is a Lewis acid. No, nucleophile is a Lewis base. Next, ammonia is a nucleophile. That is also correct. Nucleophile attack low electron density. Yeah, low electron density is nothing but electrophilic site. Yeah. So B is the not correct. Which statement is not correct? B. Yeah. Next, consider the following compounds. 1, 2, 3. There are 3 compounds. Hyperconjugation किधर होते? किधर होते देखो. This is sp2 and this is sp3. Actually hyperconjugation होने के लिए sp2 sp3 लिंक चाहिए. This is the beauty. क्या चाहिए? sp2 sp3 चाहिए and sp3 कंपल्सरी अल्फा हाइड्रोजन भी चाहिए. At least one alpha hydrogen required. Then hyperconjugation possible. Hyperconjugation explains stability of free radical carbocation alkene. That is the logic. Yeah. So first structure sp to sp3 link is there, but there is no hydrogen. There is no alpha hydrogen. So technically first one hyperconjugation not possible. If you look at second one, pH means phenyl benzene ring. So there is no such type of link. Actually you have to take like this. This is the meaning. So technically what happened? Carbon free radical means sp2. Benzene ring double one means sp2. There is no link. What was required? sp2 sp3 required, but here sp2 sp2 no. Look at this one. Yeah, this is sp2 and this is sp3 and one hydrogen possible. Yeah, this one shows hyperconjugation. Third one, B is the right answer. Next, in which of the following compounds the carbon chlorine bond ionization shall give most stable carbonium ion? This is very, very important. Haloalkanes, haloarenes order. Actually, haloalkanes, haloarenes reactivity order completely depends upon stability of carbocation. So this is the order. TBA-SPM, which means tertiary greater than, benzyl greater than, allyl greater than, secondary greater than, primary greater than methyl. That's it. Tell me now. After breaking Cl, here you will get the tertiary carbocation. Next, here you will get secondary. Here you will get benzyl. Here you will get secondary. Very simple. Tertiary. Where is tertiary? First one. Yeah, first one is the right answer. Last question. The number of structural isomers possible from the molecular formula C3H9N. Here they are not asking particularly 1 degree amino, 2 degree like that. So the number of structural isomers possible from the molecular formula means whatever primary, secondary, tertiary, all possibilities you have to find. So all amines, to find all type of amines, this is the formula 2 power n minus 1. N is nothing but number of carbons. How many carbons? 3 carbons, C3. Then 2 power 2. 4 is the right answer. Clear now? If they ask only primary amines, you can use this formula 2 power n minus 2. To find only primary structural amines, this is the formula. All type of amines, this is the formula. Clear? Yeah. Thank you. Please like.